Recently, many technologies have emerged in the field of AI video generation. If we look at each of these techniques individually, the improvement to the video quality might not be very obvious. However, if we use these technologies in combination, the overall video quality will see a qualitative leap. Take a look, this is an image-to-video workflow. Let's look at the generated video. The resulting video achieves excellent results, whether considering the actions, the color, or the consistency of the character. Here, we utilized a combination of the several techniques we just mentioned. I have conducted many tests with this combination method, and every result has been fantastic. In the videos I generated, I tried my best to use a vertical resolution. This makes the overall video look more realistic and lifelike. So, what is this combination method? Next, we will analyze it step by step. I have built the workflow on RunningHub. You can access this platform through RunningHub in the ComfyUI space. RunningHub is an excellent online workbench. This is because whenever new technologies and new extensions appear, they follow up immediately. You can register for RunningHub using the invitation link in my video description. This grants you 1,000 free credits. Additionally, logging into RunningHub daily will also give you 100 free credits, allowing you to test your own workflows. Next, let's look at the first technique we are using. This technique involves a new model, lightX2V. You should all be very familiar with this series of models, as we often use them. They typically offer acceleration and video optimization effects. Today, we need to focus on the model with 1030 in its name. We can see that there is more than one version of this model. The only difference lies in the precision, such as int8 or fp8. You can download different models based on your needs. Here, we recommend using the fp8 version. The 1030 refers to the version upgraded on the 30th of October, but note that we only have the high noise model here, not the low noise model. This is because lightX2V is more proactive in updating the high noise model, as the high noise model largely determines the video composition. What about the low noise model? Take a look. There are two new LoRAs available. These LoRAs are numbered 1022, referring to the version upgraded on the 22nd of October. This set includes both high noise and low noise LoRAs. For the combination, we can directly sample using the high noise model. However, for acceleration in the low noise model, you can pair it with this LoRA to get good results. Now, let's analyze the workflow for the other techniques used here. We will explain them in detail as we encounter them. First, let's look at the main model loading. As we mentioned, I am currently loading the 1030 version of the high noise model. Since it inherently has an acceleration effect, I do not need to add any LoRA. For the low noise model, I am still using the original version of the 12.2i to V low noise model. However, I need to add an acceleration model, which is the 1022 acceleration LoRA we just showed you. Pay attention to this combination structure. Regarding optimization, I have connected CFG 0* here. We also connected Sage Attention, followed by our VAE encoder and our visual model. Next, let's look at the reference image. The reference image itself is unremarkable. I have resized it. Note that my current resolution setting is 544 by 960. In 1.2.2, if you want to achieve better realistic effects, you should ideally use a resolution like 1280 by 720. Of course, due to computational power limitations, many people may not be able to run it at such a high resolution. In that case, try to use 544 by 960. If that still doesn't work, then use a resolution like 832 by 480. The effects produced by different resolutions are indeed quite different, so you can perform your own tests. Next, we will cover the second auxiliary technique, prompt writing. Previously, prompts were written manually, which meant the dynamic feeling might not have been as strong. Note this, in just 81 frames, observe the effect of the video I generated. The overall dynamism is very strong, with many actions included. How is this achieved? This is done by using the Qwen-VL model to help us write the prompts, as we discussed previously. I used a prompt engineering method here. When we talked about the Qwen-VL model before, we already demonstrated its use. The most important aspect is generating a JSON formatted prompt. If you are not very clear on this, you can refer to our previous video. Take a look. This is the basic format of the JSON prompt we generated. We provided a very detailed description of the overall visual subject, scene, and visual effects. Especially in the area of the action sequence, we set an action for every second. Therefore, within 5 seconds, we have at least 5 prompts specifying the action. It might not fully execute every single action, but this setup method makes the dynamic feeling significantly stronger. This is the second auxiliary technique we used. Moving on, here is our core node, which we call one image to video into this node. We input the positive conditions, negative conditions, the reference image, and the encoded output of the reference image. Finally, we get a latent output in the Qwen workflow. This is generally referred to as the one video embed, which is an embedded vector. Conceptually, it is a latent representation. We use this output during sampling. This is our basic sampling setup. The settings here are the same as those in the official workflow we discussed previously. Here, we set up a total of 6 sampling steps. The first 3 steps use the high noise model sampling, and the last 3 steps use the low noise model sampling. The sampling algorithm I use here is LCM, though you can switch to others. Finally, we utilize another auxiliary technique. This technique is called Flash VSR Ultra Fast. We previously dedicated an entire video to explaining Flash VSR, but this node is an upgraded version. Why does it have the descriptor Ultra Fast appended? It means the extreme speed version, because within this node you can select the overall mode. We are currently selecting the tinny mode. You can choose tinny, long, or full. If you choose full, it is the same as the original Flash VSR model. If you want to achieve a balance between speed and quality, you can select the tinny version below, that is the magnification multiple. We usually choose 2. Note that you cannot set a magnification multiple like 1.5 here. You can only set integer magnification multiples. Also, there are options for color correction and whether to perform tile format encoding and decoding. We can leave these settings at the default node configuration. If you want to use this node, you can install the extension called ComfyUI Flash VSR Ultra Fast. Regarding its features, you can check for yourself which mode is faster or has higher quality. The installation process is quite standard. Clone it into our custom node directory and then install the extension. There's one point to note. If you have an older GPU, the installed version of Triton cannot be too high. It is suggested to be less than 3.3.0. After upscaling, we get the effect you are seeing now. Pay attention whether it is the overall quality, the maintenance of character consistency, the movements displayed by the character, or the performance of the light and shadow. I think it is all excellent. We can look at another example. This one looks very much like a typical vlog video, right? The generated effect is also fantastic. The overall movement, the camera work, and the background presentation have genuinely achieved a significant degree of improvement. Some people might ask, what if I don't really like using this specific model? Actually, the 1022 version LoRA performs excellently too. You can use the original high noise model combined with the 1022 LoRA, which will also yield good results. Look at this workflow. The overall structure of this workflow is exactly the same as the one we just saw. The only difference is right here. I used the original high noise model and added the 1022 acceleration LoRA. And here is the video we generated. Take a moment to appreciate how excellent it looks. Here is something we need to mention. Once the video is upscaled using Flash VSR, the overall footage may have some flickering. If you want the generation to be more stable, you can temporarily skip using this upscaling node. Alternatively, after upscaling, perform a frame interpolation operation to smooth out the changes and then reduce the frame rate. The overall effect will be much better this way. Let's summarize. We primarily used 3 auxiliary techniques here. The first is the new version of the high noise model or the new acceleration LoRA. The second is using our Qwen-VL model as a prompt generator. The third is the high-speed version of Flash VSR. And of course, there is one small trick, which is the resolution aspect we just mentioned. Set it as large as possible. After combining these elements, you will certainly be able to achieve AI videos with better effects. What are you waiting for? Go ahead and try it yourself. Follow me to become someone who understands AI.